Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Core network services operate in the background of every functional network, quietly enabling the systems and users to interact, communicate, and synchronize without manual configuration. These services automate address assignments, resolve domain names, keep devices in sync with coordinated time, and gather logs for monitoring and diagnostics. While users rarely see these processes happening, they are critical to the stability, reliability, and security of enterprise environments. Understanding how these services operate is fundamental for anyone maintaining or troubleshooting modern networks. In the Network Plus certification exam, questions on DNS, DHCP, NTP, and Syslog appear frequently. You are expected to match each protocol to its port, identify its core function, and recognize how it contributes to overall network operations. These services also feature in scenario-based questions that assess your ability to identify issues such as misconfigured leases, time drift, unreachable logging servers, or name resolution failures. Each protocol is essential to both daily network activity and incident response, making them critical knowledge areas for exam success and real-world administration. Domain Name System, or DNS, is the protocol responsible for translating human-readable names like www.example.com into IP addresses that machines can use. DNS allows users to type familiar names instead of memorizing numerical addresses. It uses User Datagram Protocol port 53 for most queries, making it fast and efficient. If DNS fails, users are unable to access websites, send emails, or connect to services by name. This protocol is foundational to nearly all client-server interactions on both local and global networks. DNS supports two primary query types, forward lookups and reverse lookups. A forward lookup converts a domain name to an IP address, enabling the client to reach the correct host. A reverse lookup does the opposite, resolving an IP address back to a domain name. Reverse lookups are used in logging, security auditing, and authentication systems to identify which host is making requests. Both lookup types use the same protocol and are vital to full visibility and traceability within enterprise environments. Dynamic Host Configuration Protocol, or DHCP, is used to automatically assign IP addresses to devices on the network. It also provides configuration information such as the default gateway, subnet mask, and DNS servers. DHCP uses User Datagram Protocol ports 67 and 68 to communicate between clients and servers. Without DHCP, administrators would need to assign every IP address manually, which would be time-consuming, error-prone, and unsustainable in dynamic or large-scale networks. The DHCP lease and renewal process governs how long a device retains its assigned IP address. When a client joins the network, it requests a lease from the DHCP server. The server assigns an address for a limited time period. Before that lease expires, the client must contact the server to renew it. This system ensures that addresses are reused efficiently and that unused assignments are returned to the pool. Short lease times are common in wireless or high-turnover environments, while longer leases may be used for stable, wired infrastructure. DHCP servers can also make use of reservations and exclusions. A reservation ties a specific IP address to a device's MAC address, ensuring that the device always receives the same IP, even though it's technically using DHCP. This is useful for printers, servers, or infrastructure devices that require consistent addressing without static configuration. Exclusions, on the other hand, remove certain addresses from the dynamic pool so they cannot be assigned automatically. This prevents address conflicts when static IP addresses are used for select systems. Network Time Protocol, or NTP, ensures that devices across a network have synchronized clocks. NTP operates over User Diagram Protocol port 123 and allows clients to adjust their clocks based on a reference time source. Accurate timekeeping is critical for log correlation, time-sensitive operations, scheduled tasks, and authentication systems such as Kerberos. Without synchronized time, services may reject authentication attempts, logs may be inaccurate, and devices may misinterpret the order of events. The importance of accurate time extends beyond basic timestamp. Security systems often depend on synchronized clocks to detect anomalies, enforce expiration policies, and maintain the integrity of event logs. In environments where time discrepancies exist between servers and clients, authentication protocols may fail and logs may lose forensic value. Time-sensitive operations such as token expiration, scheduled automation, and certificate validation rely heavily on precise and consistent timekeeping across all networked systems. Syslog is a protocol used to collect log messages from devices and applications and send them to a central server for storage and analysis. It uses user datagram protocol port 514 by default and is supported by nearly every networked device, including routers, switches, firewalls, servers, and appliances. Syslog helps administrators monitor operations, detect issues, and maintain audit trails. Without centralized logging, diagnosing distributed issues becomes far more difficult, and opportunities to detect problems early are often missed. Syslog messages are categorized by both facility and severity. Facility refers to the type of system generating the message, such as the kernel, mail server, or authorization system, while severity defines the urgency or seriousness of the message. Severity levels range from informational messages and warnings to critical alerts and emergencies. This structured categorization allows administrators to filter logs, respond to events, and prioritize issues appropriately. Real-time monitoring tools often rely on Syslog messages to trigger alerts and initiate automated responses. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. A Syslog server acts as the centralized destination for messages generated by multiple devices across the network. This server receives logs from routers, switches, firewalls, and servers, storing them in a searchable, time-stamped format. By collecting logs in one place, administrators gain visibility into the behavior and health of the entire infrastructure. In network operations centers, Syslog servers are used for both real-time monitoring and historical analysis. Logs can be filtered by severity, device, or time, helping to pinpoint problems and analyze events over time. When comparing DHCP to static IP address assignment, the benefits of automation become clear. DHCP reduces manual effort, decreases the likelihood of configuration errors, and speeds up device onboarding. For general-purpose clients such as laptops, desktops, and mobile devices, DHCP is the ideal solution. Static IP addresses, however, are preferred for devices that provide consistent services, such as servers, printers, or routers. These systems benefit from fixed addressing to maintain consistent reachability. DHCP reservations offer a hybrid model by allowing dynamic assignment with fixed outcomes. Caching domain name system caching helps optimize performance by storing the results of previous lookups locally. When a DNS client receives a response from a query, it stores that answer temporarily. If the same query is needed again, the client can use the cached data rather than contacting a DNS server again. The length of time a result is cached is determined by its time to live value. A longer time to live reduces lookup frequency but can cause outdated information to persist. A shorter time to live improves freshness but increases query volume. The structure of the NTP system is hierarchical and based on stratum levels. Stratum 0 refers to highly accurate time sources such as atomic clocks or GPS systems. These devices provide the most precise time but do not communicate over a network. Stratum 1 devices connect directly to Stratum 0's sources and distribute time over a network. Clients that sync to Stratum 1 servers become Stratum 2, and so on. This cascading structure ensures scalability and minimizes the load on primary time sources while still maintaining a high level of synchronization accuracy throughout the network. Troubleshooting DNS and DHCP issues involves checking both the service configuration and the network path between the client and the server. For DHCP, the first step is to verify that the server is online and reachable. If clients are failing to obtain addresses, check that the DHCP scope is not exhausted and that no exclusions are incorrectly blocking assignment. For DNS, ensure that the server is reachable, that queries are using the correct address, and that records are properly configured. Misconfigured domain records or expired leases can result in failed lookups or unreachable services. Centralized logging through Syslog is essential for maintaining compliance and audit readiness. Organizations subject to data security regulations are often required to maintain logs that show who accessed which systems and when. Syslog allows those records to be stored securely and reviewed when needed. Logs are also critical for forensic investigations following a breach or suspicious activity. By analyzing historical Syslog data, administrators can determine how an incident unfolded, which systems were involved, and what actions were taken by users or attackers. From a security perspective, DNS and DHCP are frequent targets for attackers because of their foundational role in network communication. DNS poisoning, rogue DHCP servers, and spoofing attacks are all techniques that manipulate these services for malicious purposes. To mitigate risk, access to these protocols should be restricted using access control lists or firewall rules. Monitoring DNS and DHCP logs via Syslog helps detect unusual behavior such as repeated failed lookups, unauthorized offers, or rapid lease changes. Awareness and monitoring of these services can stop many attacks early in their life cycle. On the Network Plus exam, expect to match each protocol with its correct port and understand its role in the network. You may be asked to troubleshoot a situation where a client cannot resolve a domain, fails to receive an IP address, or logs cannot be found for a failed device. Understanding how each of these services operates and how they interact with each other allows you to analyze complex problems and identify their root causes. DHCP assigns addresses that DNS resolves into names, while Syslog logs all activity, and NTP ensures that everything is time-stamped consistently. In summary, core network services such as DNS, DHCP, NTP, and Syslog form the operational fabric of any functioning network. They support address automation, name resolution, clock synchronization, and event visibility. These services work together to maintain system availability, user accessibility, and administrative control. The Network Plus exam will test your understanding of how each one functions, what port it uses, and how it contributes to a secure and reliable network infrastructure. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cyber Security Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.